The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond. Yes, benmail@ybcc.edu and I'll respond as soon as I can. Okay, so today we're going to review for the Chapter 8 test. And to start with, we have some questions that people requested. So let's get started on that. Okay. First of all, let's see. This is from section 8.9. Number 12. And we see it over on the left side of the screen. Can everybody see the web assigned screen as well as the whiteboard? Just somebody tell me yes or no.
Yes.
Thank you. All right. So number 12, it says the distance that a car can go varies directly as the number of gallons of gasoline it consumes. If a car can go 176 miles on 11 gallons of gas, how far can it go on a full tank of 19 gallons? All right, so we're talking direct variation. It says the distance that a car can go varies directly. So how about if we let D equal distance? It varies directly as the number of gallons of gasoline it consumes, and we'll let G equal number of gallons consumed. Okay. So now that we've identified our variables, it says D varies directly as G. D equals KG. All right. Any questions about how I came up with that D equals KG? Okay. If a car can go 176 miles on 11 gallons of gasoline, how far can it go on a full tank of 19 gallons? So initially we have 176 equals K times 11. So let's solve for K. So K equals, let's see, what is 176 divided by 11? Okay, 176 divided by 11 is 16. All right, so now that's going to go up here, giving us D equals 16G. Then it says, how far can it go on a full tank of 19 gallons? So D equals 16 times 19. And let's see what we have. 16 times 19 is 304 miles. Any questions on that? Let me ask you this. Can you tell me in this problem, 16 represents K, but what is that 16? That's the gas mileage. The car gets 16 miles per gallon. Anyway, all right. Next up is number 16. So this is, again, 8.9, number 16. It says the power in watts lost in a resistor in the form of heat varies directly as the square of the current in amperes passing through it. The constant of proportionality, which is the same thing as the variation constant, is the resistance in ohms. What power is lost in a 4 ohm resistor carrying a 3 ampere current? Okay, so let's see. We're talking direct variation, the power in watts lost in a resistor. So P is going to equal power lost. Varies directly as the square of the current. C is going to equal the current. Okay, so the power varies directly as the square of the current. So we get P equals KC squared. Okay. And then it says, what power is lost in a 4 ohm resistor? So that's C. In a resistor. So P equals K carrying, oh, the power, let's see, it would be what, a 4 ohm resistor? So hang on. What power is lost to a 4 ohm resistor carrying a 3 ampere current? So the current is 3. So 4 equals K times 3 squared. Okay. So let's see here. So we have 4 equals 9K, 3 squared. Okay. Resistor varies directly. I'm actually a little confused about this problem. So hang on. Pick it up here. Okay. So the problem was my incorrectly identifying that the 4 ohm resistor was K. Kind of tricky there. So P stands for the power lost. K stands for the resistance. Right here it says that. Okay. And let's see, the square of the current. So what we get is P equals 4 times 3 squared, which is 4 times 9, which is 36 watts. Yeah, that threw me a curveball because I wasn't expecting them to give us the variation constant. Even though, so you got to really pay attention to the units. All right, well, Mr. Mayo 0, the book 1, or something like that. Okay, we good to go on that one? I'll take that as a yes.
Yes, sir.
Thank you, ma'am. All right, number 17. See if I can redeem myself here. Probably not, but I'll try. The pressure of a certain amount of gas is directly proportional to the temperature and inversely proportional to the volume. Okay, so we've got P is pressure. T is temperature, and V is volume. The pressure of a certain amount of gas is directly proportional to the temperature and inversely proportional to the volume. Okay, so we've got that mixed combo there. We've got direct and inverse variation going on at the same time. A sample of gas at a pressure of 1 atmosphere, so that would be P, occupies a volume of 1 cubic meter, that would be V, at a temperature of 274 degrees Kelvin. Okay. When heated, the gas expands to twice its volume, but the pressure remains the same. To what temperature is it heated? Okay, so first of all, we can figure out what K is. So we've got what? 1 equals 274 K. Divide both sides by 274. So K equals 1 over 274. All right. So then we're going to put that up in here. And our formula becomes P equals 1 over 274 T over V. When heated, the gas expands to twice its volume, but the temperature remains constant. So the temperature before was 274, right? So now it's still going to be 274.
Mr. Mayo,
Have I messed up again?
it says the pressure remains constant, not the temperature. Sorry.
I see that. I see that. No, I'm definitely having a great morning here. I'm glad that somebody as in you are on top of things here. Okay, let's see here. So let's see. Okay, let's go back here. Of course, now I've lost complete confidence, as have you as well. So you won't believe anything I say from here on out, but I'll still try my best. Okay. See if I can read this correctly. A sample of gas at a pressure of 1 atmosphere occupies the volume. When heated, the gas expands to twice its volume, but the pressure remains constant. So the pressure would still be 1. Oh, that was good. Pressure would still be 1, right? Pressure remains constant. The gas expands to twice its volume. So that would be what? 2.
2.
Okay. To what temperature is it heated? And we've got what? 1 over 274 T. So far, so good?
Yes.
So now we've got everything but T. Let's take this thing and deal with that separately. So we've got 1 over 274 divided by 2, which is 1 over 274 divided by 2, which is 1 over 274 times the reciprocal, which is 1 over what? 548. Okay. So now I've got 1 equals 1 over 548 T. What are we going to do to solve for T? We're going to multiply both sides by 548. So T equals 548 degrees. And what was this, Kelvin? So basically, when we, let's see, if we keep the pressure the same and we double the volume, it also did what? It doubled the temperature. Well, there you go, some basic chemistry. So what have we learned from this? You don't want me as your lab partner in chemistry because the lab will probably blow up because I'll have done the calculations wrong. All right, so hang on. I'm going to stop that sharing. Give me just a minute here and go back and look at some other questions. And let's see. This is chapter review. And I know you can't see this yet. Okay, so now go back here. All right. So now we're looking at the chapter 8 review. And this is number 1. It says, let f of x equals 7x plus 6 and g of a equal a squared minus 4a plus 4 over 8. Find g of 6. Now, what confuses some people about this problem is this whole thing. They're asking us for g of 6. So the fact that f of x equals 7x plus 6 has no bearing on the problem. Well, why is it even there? Is it there to confuse us? That's unfair. Well, in real life, you often are faced with information and you have to go through and look at the information and decide what's relevant to the problem, what isn't relevant, okay? So we're looking for G of 6. So we're going to take this formula and put in 6 in the place of A. Let's see, 36 minus 24 is 12, plus 4 is 16, over 8 is 2. So G of 6 equals 2. There you go. Any questions about that? Okay, and now we're going to look at, let's see, number 23, I think it is. 23, yeah, okay. So this is still the Chapter 8 review, number 23. Solve the absolute value equation. Enter your answers as a comma-separated list. If an answer does not exist, write enter D and E in capital letters. Okay, so here's our original absolute value equation. Let's see, 4, 1 minus x plus 1 all over 4 equals 5x minus 2 all over 5. Okay, one thing that we can do that'll save us time, we can simplify what's inside of the absolute values before we take them outside. So in the case of the one on the left side, we're going to get, this is going to be what, 4 minus 4x plus 1 all over 4, which we could further simplify into negative 4x plus 5 over 4, combining like terms, like terms, there we go. So I can do that before I do anything else. Why would I want to do that? Because otherwise, if I don't do that first, when I split it up into my two equations, I'm going to have to simplify that whole thing 2 different times in 2 different equations. Okay, so I've simplified what's inside on the left side. So now my two equations, one of them is going to be negative 4x plus 5 over 4 equals 5x minus 2 over 5. Okay, that's one of them. Or negative 4x plus 5 over 4 equals the opposite of 5x minus 2 all over 5. Okay, again, I have to take the opposite of the whole thing. So let's look at this first one here. I'm going to multiply both sides of the equation by the LCD, which is 20. So 20 here and 20 there. I get negative 80x. Oh, wait a minute, though. I don't need to do that, do I? Why am I multiplying by the LCD? To clear the fractions. So what I can do is this. 20 over 4 is 5. Now I'll distribute the 5, and I get negative 20x plus 25 equals, and over here, reduce it down, distribute the 4, 20x minus 8. We okay with that? I'll take that as a yes. I'm going to go in and solve for x. So let's see, I'll subtract 20x from both sides. So I get negative 40x plus 25 equals negative 8. Subtract 25, negative 40x equals negative 33. Divide by negative 40x equals 33 over 40. So there's one solution, okay? Or at least one possible solution. Now, let's take a look at this second equation. Again, we'll multiply both sides by the LCD, which is 20. 20 over 4 is a 5. So I get negative 20x plus 25. 20 over 5 is a 4. So I've got 4 times -1 times 5x minus 2, okay? So this is like -1 times 5x minus 2 times 4, right? So I could take -1 times 4 first and then distribute that. So that gives me -20x plus 10. Okay, well then let's see, let's add 20x to both sides. And I get 25 equals 10. Well, that's not, oh, so that leads to a dead end. So we only have one solution. Any questions about that? Okay, well, that takes care of the specific questions that people emailed with. So emailed me. Before we go on with my review stuff, do any of you have any other specific questions you'd like to look at? Okay, I'll take that as a no. So let's do this. Give me just a second here. I'm going to go back to the regular whiteboard screen. And okay, give me again that. Okay, right there. And here. Okay, so once again, you should be able to see just the whiteboard screen.
Yep.
Okay, great. All right. So let's see here. We started with section 8.2. And the main thing with 8.2, well, there were two main things. One of them was getting used to function notation. So for instance, if I have f of x equals 2x plus 4, and I want to find f of -3, that's just like having y equals 2x plus 4, and I'm trying to complete the ordered pair -3 comma whatever, right? So in both cases, 3 goes here, 3 goes here. So f of -3 is 2 times -3 plus 4, or -6 plus 4, or -2. Just like over here, y equals 2 times -3 plus 4, -6 plus 4, -2. So f of -3 equals -2 is the function notation way of writing the ordered pair -3 comma -2. Okay, so whether you're just writing it out that way or you're locating it on a graph, the same thing. So let's say we're looking at, where is it here? We've got a graph, and oh, let's see here, it does this. So we've got this function, and we'll call it function f. So f of 3, we'd be looking at the graph and saying, where is x equal to 3? Right there. So what's the corresponding y value? 1. So just like we could say the coordinates of this point are 3, 1, the function notation for it would be f of 3 equals 1. Okay. Likewise, f of 1 equals 3. And f of -2 equals 2. All right, are we okay with how that works? Any questions there, clarification or anything?
No, thank you.
Okay, all right. We also talked about domain and range. Let's say we've got, we've got this function g, okay? So the domain, since this thing is going over as it goes down and over as it goes up, the domain would be all real numbers. The range, since it's going down and up forever, would also be all real numbers. But let's look at one that's perhaps not so obvious. Let's say we've got this thing. Okay, so now the domain is still all real numbers. Nah. Because it continues to the left forever and to the right forever. So domain goes from smallest to largest along the x-axis. But the range, this goes down to negative infinity. So it starts at negative infinity, but the highest range value is 3. Okay, there's no y value greater than 3 up here. Does that make sense? Any questions about that? Okay, we also talked about, let's see here. Finding the domain of a function without a graph. So you've just got the actual function, let's say f of x equals 2x plus 4. And we want to know what the domain is. Well, we've only dealt with the restrictions of dividing by 0. Since there's no variable in a denominator in this function, there's no way we can end up dividing by 0. So there's no restrictions. So the domain would be all real numbers. However, let's say we've got this situation. Now, the denominator could be 0, so we could have it undefined, so there are going to be some restrictions. So let's take the denominator and find out when it would equal 0. When x is -2, okay? So in other words, g of -2 would be undefined. Therefore, -2 is not in the domain. So that's the bad guy. So the domain would be all real numbers except x cannot equal -2, or so all real numbers except -2. Writing it in interval notation, it looks like this. So this is everything from negative infinity up to, but not including -2, and then everything after -2 on up to positive infinity, and then this union symbol, but it's excluding -2. Right. You okay with that? Good to go, hopefully? Well,
Yes.
all right. Let's see, graph each function. So think in terms of y equals mx plus b. In fact, let's go back up here. I'm going to do this. I'm gonna do that and open it up again so I can delete my graphs. Okay, so let's say we've got f of x equals 2/3 x minus 2. That's in the form y equals mx plus b. So the slope is 2/3 and the y-intercept is -2. So you begin at the y-intercept of -2 and the slope is 2/3. So you go up 2/3, up 2/3, and we get graph that looks like that. So that's the graph of f of x equals 2/3 x minus 2. Any questions about that? Okay, then we had a bunch of things that were actually a review going back to chapter 3 if you took beginning algebra or math 85 or math 84, or again, some beginning algebra class somewhere else perhaps. And we had a bunch of rules. First of all, this y equals mx plus b slope-intercept form. We just applied that. There's the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. There is the fact that parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals of one another. Let's see here. Oh, an equation in the form y equals a number or y equals a constant is a horizontal line. X equals a number is a vertical line. Let's see, the slope of a horizontal line is 0. So you'd say m equals 0. I think that's all. Do any of you want any examples of any of these specific rules being applied?
No, I'm good. Thank you, though.
Okay. Well, then let's go on to section, let's see, what was next? 8.3. In 8.3 was basically identifying points on the graph using function notation. Okay, so that's where we had some graphs already drawn, you know, something like this, and then you were supposed to find, you know, like f of 2, and then you'd come up here and say, oh, f of 2 is what, basically 1/2, and those kinds of things. So it was sort of a visual of identifying ordered pairs on the graph, but using function notation. Okay, let's see. Oh, compound inequalities. Let's take a look at that. That was section 8.4. Couple things to remind you of in compound inequalities, or just inequalities in general. If you multiply or divide both sides of an inequality, you change the direction of the inequality sign. So if you've got like negative 2x less than 4, and you divide both sides by negative 2, you change the direction of the inequality sign. Okay. We dealt with union and intersection. Union was also, they used the word or, and intersection, they used the word and when they dealt with inequalities. Let's see. We looked at solving an inequality or system, compound inequality, graphing it on a number line, and then writing it in interval notation. Is there anything there that you want me to look at specifically?
So we only switched the
Sign.
So we only switched the equal sign when it's only a negative, positive,
Okay.
and
If you multiply or divide both sides of the inequality. So here's another example. Let's say I've got negative 3/4 x greater than or equal to 5. Okay. So I would multiply both sides by the reciprocal, which would be negative 4/3. That is the reciprocal of the coefficient. Okay. So this is all going to reduce down to x. And over here, we're going to have negative 20/3. But because we multiplied both sides by a negative, we'll change the direction of the inequality. So if you multiply both sides or divide both sides of an inequality, then and only then you change the direction of the inequality sign. Okay. Gabe, is you okay with that? Or you need more examples?
no, yeah, I got it.
Okay. All right. Anything else there? 8.4. Okay.
Can you go over notation form again, please?
Notation form. Interval notation.
Yes, please.
Okay. Okay. Tell you what, let's take this one. How would you write that in interval notation? It would look like this. Because x is less than or equal to negative 20/3. So graphically, you'd have, let's see, let's use this. You'd have this bracket and an arrow going to the left. And so interval notation wise, you'd have, it's going to the left to negative infinity up to and including negative 20/3 because it has the equals as part of it. Does that make sense?
Yes.
Okay, let's take a look at this one. That would be, let's see, -2 to infinity. And on the graph, it would look like that because x does not equal -2, but it's everything greater than. So after -2 on up to infinity, never put a bracket on infinity or negative infinity because that's not a specific endpoint. That's just a concept of it going on forever. Do you want more examples? I can do that if you want. Just let me know.
No, thank you. I understand now.
Okay, everybody else good with that? All right, let's see. Absolute value equations, solving those. If you've got the absolute value of A equals, I'm going to say positive number, then A equals positive number, or A equals the opposite of the positive number. Okay, do you understand that notation? It's just my shortcuts. If the absolute value of A equals 0, you're going to have just one equation because you're going to have that or that, but the opposite of 0 is equal to 0. So this is redundant. So you'd only have that form. So if you've got an absolute value set equal to a positive number, you're going to have two possible equations. Go through and solve them. Check your work. Absolute value equal to 0, you're going to have one equation. Solve it. Check your work. Absolute value equal to negative number, you're not going to get a solution, but I believe WebAssign asks you to go through and break it down into the two equations. You solve them, you check your work, and you find that neither one of the solutions work. So that's where you get those extraneous solutions, but they don't work. Okay. So there's technically no solution, but depending on what WebAssign asks you to do, you might still have to go through and solve them and then see that, oh, they don't work. Okay. If you have an absolute value equals an absolute value, you're going to have this or that. What's inside equals what's inside. What's inside equals the opposite of what's inside. Again, solve each equation, check your work. Let's see. What else did I want to talk about to do with that? Are there any of these specifically that you want, any types you want me to do?
Can you do some with fractions?
You betcha. Okay. Let's see here. Fractions. How about this one? Oh, I know what I forgot to say. You need to isolate the absolute value before you break it down into separate equations. But we'll go ahead and look at one of the fractions and then remind me if I forget, I'll do one that like I was just talking about. Okay, so 11/12 equals the absolute value of x over 3 minus 3x over 4. Okay, now what I can do here to again make life easier for me and not have to do something twice is I can take what's inside the absolute values and take those two fractions and put them together as a single fraction. Okay, so over here off to the side, I'm going to go through and do that. So to add or subtract those two fractions, we'd need a common denominator of 12. We'd have to multiply the first one by 4 over 4 and the second one by 3 over 3. So we'd end up with negative 5x over 12. Any questions about how I did that? So now I can come back over here and say that. Okay. So now I've got an absolute value isolated set equal to a constant. So either what's inside the absolute value equals 11/12, or what's inside the absolute value equals the opposite of 11/12. Yeah. Okay, so far? So to solve this first equation, if I multiply both sides by -12/5, that is the reciprocal of the coefficient of x, that reduces down to x equals, and this is what, -1/1, so we get -11/5, okay? Now, second equation, I'm going to multiply both sides by -12/5. And I get x equals 11/5. So I get two solutions. We okay with that?
Yes, thank you.
All right. Let's see, I talked about getting rid of everything, isolating the absolute value. Let's see here. Here we go. -10 times the absolute value of 16x plus 4 minus 3 equals -3. Now be careful, because you might look at this and say, oh, it's equal to a negative number, so there's not going to be any solution. Careful. It has to be, the absolute value has to be isolated and then equal to a negative number when there's not going to be a solution that works. So first of all, we've got to isolate the absolute value. So I'm going to add 3 to both sides. Okay, so now I've got -10 times the absolute value of 16x plus 4 equals 0. Then I'm going to divide both sides by -10. So the absolute value of 16x plus 4 equals 0. So now I've isolated the absolute value. It's set equal to 0, which means we're just going to have one unique equation because the opposite of 0 is still 0. All right. Subtract 4. 16x equals -4. Divide by 16x equals -1/4. Let's plug that in to the equation. So we've got -10, absolute value of 16 times -1/4 plus 4 minus 3 equals -3. 16/4 is 4/1. 4 times -1 is -4. -4 plus 4 is 0. -10 times the absolute value of 0 minus 3 equals -3. What's the absolute value of 0? It's 0. -10 times 0 is 0. 0 minus 3 is -3. -3 equals -3. And it checks. Okay. Lastly, we had variation. And I did a great example of screwing those up earlier this morning, as you will recall. But in section 8.9, you've got direct variation, inverse, and joint. In each case, K is on top in the formula. It may or may not be mentioned, but it exists in all different forms of variation. Okay. So what you've got to do, go through, read the problems, identify the variables, be careful, as I learned the hard way again, to make sure you've got things identified correctly. Go through, and if they don't already give you K, they would give you enough information to determine what K is. Then you put K back in the equation and follow up with the follow-up question. Okay. Is there anything more you want me to do with the variation?
No, thank you.
All right, so I will be back today at 1:15 with an office hour. All right. Tomorrow, there will be no Zoom class at 10:30. Basically, you've got till 11:59 tomorrow night to finish the Chapter 8 test. Keep in mind, once you open it, the timer starts, so you can't come back several times and work on it. So make sure you've got, time where your kids aren't going to interrupt you or whatever, or you don't have to go mow the lawn or something like that. Anyway, besides, it'd be a good excuse to get out of mowing the lawn. I got to take a test. Mr. Mayo said. Anyway, I'm rambling on here. Have a great rest of the day. I'm going to stop the recording